Hi everyone, welcome to Learn with Preeti. Myself, Preeti. I have basically 5+ years of experience as a backend developer. Let's learn together. I started this channel today only. I will upload as much as I can. Today let's start with the multi-threading. So even though I have 5+ years of experience, if you come across with any mistakes in my videos, please let me know so that we can learn together. If you have any questions or any comment on my videos, please include in the comment section. So as you all know, in Java, multi-threading is a very crucial part. If we attend 6+ interviews, or at least we will get this question, multi-threading concepts at least 2 to 3+. If you are 5+, for sure multi-threading will be coming in the interview section. So I have prepared this content. I have come up with some tricky multi-threading concepts that will be really helpful for us interview sections. Let's go with the question number 1. Start versus run. Start versus run in the thread. Okay, this is the output provided. So we have one class test. One main method is there. Thread t equal to new thread system.out.println inside thread and t.run system.out.println of main thread. So if we are seeing this question, the first thing we need to identify how many threads will be created in this block. Actually only one thread is, which is main thread, only created till now. The reason why there is no child thread created is because we have not called the start method. Start method is the one which is responsible to create a child thread by including the child thread in the JVM and creating a scheduler for that, registering the thread in the JVM and schedules the threads. So here we are not calling a t.start. Instead we are calling t.run. So thread here if you see, we include a thread t equal to new thread. It has a this thread is a class of a class that is present in the Java. So it has one constructor which consumes runnable as an argument. Here inside this we have runnable one, and what we are doing, we are calling the run method. So run method, what it will do, it will execute the run method of the thread class, which has a empty implementation. We are calling t.run. Run method is already there in the thread class. So we are not overridden the run method. Automatically the run method that is present in the thread class will be executed. The run method in the thread class is an empty implementation. So output what we will get is inside thread, main thread. The question comes in, this is not multi-threading as we are not calling t.start. If we change the line 1 with t.start, then output will be unpredictable. Inside thread, main thread, or main thread, inside thread, because in thread we can't determine which thread will get the execution first. Based on the JVM will assign some particular schedules to the priorities to the thread. The priorities we can't determine. That's completely in hands of JVM only. Next, moving on to question 2. So we have a thread t equal to new thread system.out.println of thread.get current thread.get name, t.run also we have, t.start also we have. Now the question is, how many threads are created? One new thread will be created along with the main thread. Why one new thread is created? Because we are calling t.start method. T.run does not create any new thread. T.start creates a new thread. What will be printed? Output is guaranteed because t.run, this will invoke runnable of thread class. We have a t.run, this will invoke the runnable of thread class, executes completely before t dot start is even called. So actually thread main will always print first, then start creates a new thread, then start creates a new, this will prints later. So final behavior is main thread 0. Got it. So here only one new thread will be created, which will be created along with the main thread. The question comes in whether any order will be maintained or not. Order is guaranteed because order is guaranteed order is guaranteed because t dot run will be executed before t dot start, right? So here in this line only our new child will be created. If we have a t dot run after t dot start, then we can't determine the output, but we have a t dot run even before our child thread gets created, so the output will be main thread of 0. Okay, any exception will be occurring? No. So moving on to the next question, question number 3. We have a class public static void main thread t equal to new thread system dot out dot println of running t dot start t dot start. Will this combine? Yes. Running time behavior, we get illegal thread state exception. Why? Okay, consider to make this is to make you understand this much better, let's consider you're born. Okay, you're just newly born. You made one mistake. Let's consider instead of you are very much perceive in the cooking, but you have taken due to some parents force or whatsoever, you have taken some another course. Let's consider architect or engineering whatsoever. After that you even completed the degree also in that engineering. Let's consider you completed engineering. Now you made many mistakes in your life. Let's consider even even you have even you have failed in exams, or sorry, let's take this example, forget about the previous exam, apologies. Let's consider you are a very working hard person. From class you're born, your family members are saying when you enter into 10th, this is a phase where your future life will be decided. Then you are working very very hard. You're putting so much effort for the entire 1 year. You're scoring 99%. You even receive state first. Then you're going to 12th also, parents are again saying, hey, this is a phase, you will be decided which course you need to pick. So you're working very very hard. There you are scoring above 95%. Then you're moving to college, whatever, doctor, engineer, teacher, degree or whatsoever. There your parents are saying, in college life again you need to work hard. So when you're turning back, there you are saying, Arey, what is here, I was studying continuously for all these years. When I turn back, I can see only preparation. Now you're going to Brahma. Okay, Brahma, or you, who's your favorite god? Hare God, I don't like this life. Can you make me to born again, reborn again? Then your god says, no no no, once you started your life, you need to complete that life. Okay, so just for fun, to make this understand easier, I have given this example. So thread like how human being have some life, like born, childhood life, teenage life, middle age life, and then elderly life, and then death. uh, like that, thread also has some life cycle: new, runnable, running, terminated. When you include t dot start, thread moves from new to runnable. Okay, JVM creates a OS level thread. When you call t dot start again, what will happen? Thread is no longer in the new state. So JVM will throw illegal thread state exception. Thread can be started only when its lifetime is completed. You cannot restart or reuse the same thread object again and again. If you have created another thread object, let's consider thread t1 equal to new thread. There you calling t1 dot start. Then we can say this will throw illegal thread state exception. But you're calling start method on the same thread object, so obviously you will get illegal thread state exception. Okay, so moving on to question number 5. We have a class, one normal class which extends thread. As we all know, thread class has run method, so we need to override. Okay, we have class test. We are creating the object for the child class, and then we are calling the run method. Now what will happen when we call the run method? Will there be any child thread will be created, or we will proceed only with the main thread? The answer to that question is no new thread will be created, because we are calling the run method. Run method of child class will be executed. Okay, which is it will be treated as a normal method execution. So we will get child thread as an output. This is not a multi-threading. When you are calling t.run method directly, it behaves as a normal method. It executes in the main method. No new thread is created. Only t.start creates a new thread. Internally calls run method in the new thread. Okay. So moving on to question number 6. Override start method. Okay. So far we have learned what is the purpose of a start method. Start method is responsible to register the thread in JVM and including the setting the priority for the thread. Now if I override the start method, what will happen? Thread start method in the thread only is responsible for all these things. Now I am overriding. Then no new thread will be created. Thread will not be registered in JVM, and job scheduling priority will not be scheduled by job thread scheduler. So here if you see, we are calling t.start, but actually when we call t.start, run method will be invoked. But in our case, start method will be executed, which will get start method as output. Will run execute? No, because we are overriding the start in thread class only responsible to register the thread in JVM with thread scheduler. As we are overriding and calling the start method, no new thread will be created. Why is this dangerous? This is not a multi-threading concept itself. You are breaking the thread life cycle concept of thread class. Okay, t.start, what it is, registers a thread with thread scheduler, creates a new call stack, then internally calls run method. Okay, so now moving on to the question. So if you are calling the t.start directly, you are breaking all these 3 steps which are really required to register the thread in JVM, creates a new call stack, and internally calling the run method. You are completely breaking these 3 steps and directly calling the start method. So that will not be considered as a multi-threading itself. Now moving on to the question number 7. We have a class test public static void main thread t equal to new thread t.start system.out.println t.run. So if you see carefully, we have a start method. What it will do? It will internally invoke the run method of the thread class. So we will get one hyphen child something. Then after that, here we have a 2. This one will be executed by child thread or main thread? Main thread. whatever that is present inside the thread class, that will be executed by child thread. Once we call the start method in that current object, this, as we are not included this anywhere inside the thread object, this will be printed by the main thread. After this we have a t.run. This will be executed by this will be considered as a normal method execution. We will have 1 : main. You can see the output, right? Thread 0, 2 main, 1 main. So these are the valid outputs. The output we can't predict because the priorities that we can't determine, right? Maybe main can get the chance first, child can get the chance first. So many permutations we will be getting because thread scheduling is not guaranteed. How many times thread constructor is invoked by the main thread, so main will print first. Our question may come up, yeah, we have this constructor first, why this one is not printed, right? Constructor is called by main thread, right? But that has nothing to do with the execution order of prints. The order depends on when the scheduler runs the new thread after start, not on who created the thread. So you're getting the point, right? Who created the thread, that doesn't matter. The actual point is after this t.start we have created one new child thread. The order of execution depends on the thread scheduling. I request JVM to start a new thread only. Okay. Now moving on to the next question, number 8. We have a class test public static void main thread t equal to new thread system.out.println thread started thread.sleep thread.start. What will happen here? If you see here, first time we have created the one object. This is like inside the run method. I am calling the t.run method. So this will not create any new thread object. This will just print call the run method which is present inside the thread, which will simply print thread started. So this line will be executed by the main thread when we call t.run. After that we are waiting for 1000 milliseconds. Then we are calling t.start. The moment we call t.start, now we will get thread started by the child thread. After this t.start, new child thread will be created. So now here in this case order is determined because we are waiting for 1000 milliseconds. Yes, multiple threads, usually no guarantee, but only if they compete at same time. In your code, first print happens before threading even begins. Okay. Second print happens after happens after. Okay. So order is guaranteed. When multiple threads are there, usually thread execution will not be determined. That's completely in hands of thread scheduling. As we are waiting for 1000 milliseconds, then order of executions are determined. Okay. Moving on to question number 9. We have created the class test. Main method is there. Thread t equal to new thread system.out.println 3.run t.start. What we are doing here, whether the current thread equal to t. Okay, what we will get compile time error. This is like a runnable. Inside this is an lambda expression, something we can say. That should be variable t is might here it's not yet initialized. So we will get compile time error. Okay. Moving on to question number 10. We have a class myThread extends thread void run class test. I have created a new object here. Just I am extending the thread and I am overriding the run method saying running in. Okay, and then I am calling run and start. If I call run method, as we discussed, what it will do, it does if you overridden the run method, then it will execute the run method like a normal method execution. No new thread will be created. So we will be getting running in main thread, because this method will be executed by the main thread. I am calling t dot start. This what it will do, internally it will invoke the run method of the child class. Okay, here what it will, the moment we call t dot start, as we discussed, new thread will be created, and new thread registers a new thread in JVM, and thread scheduling will be happening, and internally it will invoke the run method of the class. So here what we will get running in the child thread, and then main done. Okay, so we will be getting running in main done, and running in thread 0. The output sometimes we can't predict, right? So depends upon the thread scheduling. We will get first running in main done, thread 0 running in main. If a child got the priority first, then this will be coming. So based on the priority, thread priority, this will be executed. Next, so far till this part, what we have learned is the difference between start versus run. Okay, how we can create a thread is, we can create a one child class by extending the thread class. Thread class as a run method, so we need to override that run method. When we call start method on the class which we extend the thread which we have extended the thread class, yeah, something like this, then new child will be created, child thread will be created. So far this is the one way we have learned how to create a thread. Okay, and it is recommended to always override the run method. If you are not overriding the run method, then we should not go for multi-threading concept itself, because run method instead of thread method has empty implementation. Similarly, we have to call the start method. If you are not calling a start method, then we should not go for multi-threading concept if we are going for a thread class implementation, because start method is the one which is responsible to create a child thread. And here we should not override the start method. Why we should not override the start method? Because a thread register, because thread start is the one which is responsible to register thread with JVM, create a new task, and internally execute the run method. If you override the start method, we are breaking those 3 points. So new thread itself will not be created. Okay. Next, moving to the next topic, runnable. Runnable is the one, this is like how we have a thread, it is a runnable. Okay, runnable are inside that one I have included this one. Inside the thread we can pass the runnable object. Okay, so here I am creating the runnable object and passing that runnable object inside the thread. I am calling t1.run and t2.start. What here it will do? So when we call run method, no new thread will be created and it will be executing as running in main. If we call t2.start, what will happen? New thread will be created, so running in child thread. See here, running in main, running in child. How many threads are created? One new thread will be created. Which thread executes first? t1.run. Now class counter implements runnable. Okay, inside this one I have now one instance variable which I have initialized with count equal to 0. Now I am calling void, sorry, I have implemented run method. I am incrementing it. After that, what I am doing, I am creating an object for the counter and I am passing that C into the thread 1 and thread 2, and I am calling t1.start, t2.start, and then t1.join, t2.join. system.out.println of c.count. So we have some special functionality called join method. Join. So what it will do, the main thread will wait until T1 completes its execution. Similarly, main thread will wait until T2 completes its execution. So if you see here, what will happen, I am calling T1 dot start, T2 dot start at in the next line. So first a new child thread will be created, that will be keep on incrementing the count 1 2 3 4 something. After that I am again calling T2 dot start. T2 dot start, that time what will happen, again the count value will start from 0 and it will it will keep on incrementing, but we won't get the expected output because we have used the same common object. When we are calling the T2 thread with the same object, here we are using the same object, so the moment it creates a new child thread for the second thread T2, it will have the count of the T1 also. If T1 let's say the T1 incremented the count till 11, T2 will start from 12. Okay, but the problem is here we will get inconsistency. You're getting the point, right? It will be 2000 like 1997. Why it is not actual expected one is we are passing same object 2 times we are passing, so 1000 times we are running, so we should get 2000 in 2 places, but that won't get, we will get only in rare case. We will end up with 1987, 1767, something like that. Why it is not 2000? Because it is not atomic. It actually happens in 3 steps. Read the count, increment the count, write back to the count. Let's say count equal to 5. Okay, 2 threads T1 T2 execute simultaneously. Okay, here T1 T2 execute simultaneously on the same counter object. Thread 1 reads 5, thread 2 reads 5, increment 6, write 6. Final value, here you can see, right, 6 instead of 7. One increment itself is lost. So the root cause is shared mutable state, no synchronization. One thread is not waiting until another thread completes its execution. Thread interleave execution. Okay, we have lost the increment. So what we need to do in this case is we have 2 approaches. One is we can go for synchronized keyword. Other is if we don't want to use synchronized keyword, then we need to use atomic integer. What we need to include atomic integer 0, count dot increment and get. Why this work? It uses compare and swap. Atomic integer no race condition will occur. So this is one way, like using the atomic integer. Another way is there using the volatile. Attempt, let's consider we are using volatile. What will happen? Will this print 2000? No, you will get random value less than 2000. Why volatile fails here? Changes by one thread are visible to others immediately. Always reads from main memory. There is no atomicity. The core problem is count plus plus. It reads, increments and writes even with the volatile. This is not atomic. So the race condition still happens. 10 10, increment 11 11, lost, update again. Okay, so the key inside is volatile solve visibility, not atomicity. When is volatile actually useful? Good for volatile boolean equal to true, used in stop signals, stop status flags, configuration changes. When not to use volatile, counter, increment, decrement, compound operations. Okay, so if you see here, yeah, so this is the thing. Now in this way we have understood, like if we want to maintain the value consistent across multiple threads, then we can go for atomic integer. If you are doing some increment decrement, as that uses compare and swap, it will compare and then it will use compare and swap, so there is no race condition involved over there. Okay, so we will get always the expected value. But why not the volatile is because changes done by one thread are visible to other threads immediately. It is useful for the boolean cases, not for the increment cases. Okay, next, moving on to the next question, runnable inside the thread class. I have created one class which extends the thread class, and then we have one constructor. There I am passing runnable super R, and I have overridden the run method. Now I have a class test runnable R, and I am passing that runnable inside the thread. Now I am calling t dot start. The moment I call the t dot start, as we all know what it will do, it will execute the run method, right? So run method, it will execute the run method. Now the question comes in whether my thread run will be executed or runnable run will be executed. As per my understanding, this my thread run will be executed because we have overridden the run method. Let's see what is an output. Yeah, my thread run. Will runnable run, this one will get executed? No, it will not. Why? This is very tricky and important concept. When you do thread t equal to new thread or, you are passing a runnable R to a thread constructor via super R. Okay, so internally stores this runnable as a target. You override run in my thread, so now JVM will call your overridden run, not the one from the thread. So you are creating the runnable R, and you are passing there. It registers the R inside the super. The moment you call the start, it will execute this one only, because you are passing a runnable R to the thread constructor via super. So internal thread stores this runnable as a target. Also you are overriding the run, so JVM will call override run, not the one from the thread. Changing runnable after thread execution. Runnable R equal to R1, runnable R2, thread T equal to runnable R1, R1 equal to, now we are assigning R2 equal to R1, T1 dot start. Questions. Output R2. Why does it print R2? Two separate runnable objects are created. Object A prints R1, object B prints R2. Thread T equal to new thread of R1. Very important. The thread constructor stores a reference to object A. The thread constructor stores a reference to object A internally. Now T is permanently linked to runnable A, not to the variable V1. This line does not affect the thread at all. You are changing the reference variable. Now R1 points to object B, but T still points to object A. Okay, so it's like you have included the runnable object inside the thread. Okay, after that you are assigning R2 equal to R1. You are just changing the assignment, but the thread object still holds R1. That's why the moment you call T dot start, it executes runnable R1. The thread constructor stores a reference to object 1 internally. So now T is permanently linked to runnable A, not with the variable R2. R1 equal to R2. This line does not affect the thread at all. You are only changing the reference variable R1. R1 points to object B, but T still points to object A. Thread executes the original runnable A, so the output is R1. Thread stores a runnable object, not the variable. Variable can change. Object reference inside thread do not change. Okay. So calling the start on the same thread without completing the execution, as we have discussed. Moving on to the next question. So calling the start method on the same object, what we will get? Illegal thread state exception, because the life cycle itself is not completed. New runnable running dead. So when you are calling t dot start, the thread will be moving from new to running state, but you are calling again t dot start to create a new thread again, but already the thread is in running state. So you will get illegal thread state exception after illegal thread state exception. Okay. Runnable is just a task. Thread is a execution unit. So even if you can reuse runnable many times, but you cannot reuse the same thread object again and again. Here you can use 3 equal to new thread or t1 dot start, t2 dot start. This is fine. Okay. The next one. So runnable r new thread r dot start. Here we have instance variable x equal to 10. Inside that I am printing x. I am including that runnable inside this one. The moment I call start method, this will be executed. The output will be 10, but we can't change this one. If you uncomment, I will get compiled error, because lambda variables must be effectively final inside the Java captures, not variables. To mutate, we must use atomic wrappers like atomic integer. How to make it mutable? Use atomic integer. Atomic integer x equal to new atomic integer x dot set 20. Now x dot get, you will get output as 20. Run okay. So because inside this this is a lambda expression. Inside this we should not everything is final. We are not supposed to make any addition. So to make that mutable, we need to go for atomic integer. Okay, moving on to the next question. Question number 7. Runnable execution order illusion. We have a class test main method runnable r new thread r dot start. We are passing this one and then start. So the moment start method executes, what will happen? As we have discussed, run method will be executed. Then we will get thread child thread. The moment start method executed, child thread will be executed. Thread r dot run. This does not create any new thread. Run method will be executed by the main thread. So thread main output, here we can't determine thread 0 main or thread main 0. Which thread runs? Second call main thread. This will be executed by the main thread. Runnable versus callable. Okay. So this is a very important question for an interview room. So okay, before we move to this question, we have found the two ways to create a thread. One is by extending the thread class, and other is implementing the runnable. If we implement the runnable, then we need to initialize, we need to pass that runnable object inside the thread class. Which is the best optimal approach? By extending the thread class or by implementing the runnable? This is a very important interview room question. Which one is the most optimal way? Answer to that question is thread class or runnable. See, here we are extending the thread. Okay, if we extend the thread, does Java supports multiple inheritance? No, right? If we extend the thread to the class, it won't allow us to add any further classes to be extended for this MyThread class. So we will end up with always extending one class. So that is one disadvantage. But if you implement, if you use runnable, we can implement and we can add any other class which we want to extend, right? So here we can add anything, we can include comma and then add some any other class which you want to extend. So always it is recommended to go for runnable over the thread class. Okay, moving on to the next question, runnable versus callable. This is very important interview room question. Runnable came in Java 1.0. okay, very simple abstraction, meant only for executing task method. It has void run, no return, cannot throw it's basically void. Okay, it doesn't throw any checked exceptions, it doesn't return anything. But callable came in Java 5, designed for asynchronous computation. It can return, it can throw checked exception. Can you use runnable return without using column? Yes, but indirectly. How to use that is, we are implementing the runnable. Okay, the problem is race condition no guarantee multiple threads is the updated value, correct? So the approach two is using atomic integer, structured way to wait for completion. Approach 3 using future with runnable. So what we are doing here is executor service, executors dot single thread executor service dot submit. So submit of runnable returns a future. Future dot get will return the null. However, submit of this task output we will get 100. This is how you make runnable return value. Okay, so if you call that future dot get, we will get output as a 100. You are getting the point, right? The moment we are calling future dot get, the only if you call future dot get, we will get the output. Okay, as runnable is not allowing us to return the value, even atomic integer also not allow us to return the value, we can go for executor service. So we have included a single thread, so only one thread will be executed for any request. So here service dot submit, and then we are passing that task. The moment we call future dot get, then only the response will be returned. So we will get output as 100. Case 1 using what happens if exception occurs inside runnable? That depends on how we are using it. Return exception printed to console, thread dies, you cannot catch into the main thread. But using the executor service dot submit, exception is valid. Here itself you are throwing, okay, nothing printed until you call future dot get. If we use execute instead of submit, what will happen? Exception printed immediately, similar to the thread. So basically executor service has two methods. One is a execute method and another is a submit method. Submit method is like asynchronous. Only if we call the get, then only you will get the response. But when you use execute method, it is like return the response immediately, similar to thread behavior. Okay, so next question number 9, and let's see in the next video from question number 9. Okay, let's complete question number 9 and 10. We have only 2 questions left over. Let's complete question number 9 and 10. I have created one boolean running true, okay, and then overridden the run. Inside that I have while running stop. I'm creating the object, and then there I'm passing that task, and then I'm calling t dot start. Okay, the moment I call t dot start, automatically, as we have discussed, then it will override the, it will call the run method. We have run equal to true. So what will happen, the child that will keep on running, it won't come out from this run method. Then we are waiting for some milliseconds. After that, what I am doing, I am using the same object which I passed inside this one. So task dot running equal to false. I am initializing running equal to false. Running equal to false. What will happen? Running equal to false. Code will be running without a termination. Why? Thread T reads running equal to true once. CPU JVM catches it into register or CPU cache. Since there is no synchronization, JVM is free to not reread from main memory. Even optimizer loop. Each thread can have its own cached copy of variable. Main thread updates thread task dot running equal to false, but child thread may never see this change. So what actually happens in our code, the thread T starts running, it reads running equal to true, JVM CPU may cache it, local copy equal to true, loop becomes while true. Meanwhile, main thread does task running equal to false. This updates main memory only, not the thread cache. This does not, thread T does not read it from main memory. It keeps using the cached value equal to true. So loop will keep on running. The fix without synchronized is, as we have discussed, using volatile. So every thread goes to main memory. Every write is visible to all threads immediately. Stop will be printed using atomic boolean. Okay, so when we use a volatile, what will happen, instead of cache, it will go to the main memory. So every thread will go to the main memory. But if you are not using the volatile, every thread will have its own cache. Even though main thread updates it, it will update only in the main memory. Updates in the, here we have seen, right, task dot running equal to false, it updates only in the main memory. So yeah, that's right. Moving to the next question. So we have initialized here one task, and then we are passing that to T1. We are starting. Main thread waits until T1 completes. T2 or T2 dot start. We are passing the same runnable object to both T1 and T2, but here main thread waits. But here the main thread waits until T1 completes its execution. So here the order will be maintained. We will get a running thread 0. Two threads will be created, one here, but this thread execution will begin only after T1 completes its execution. Is this valid? Yes. Difference between the thread versus runnable, we can reuse the runnable any number of times. It has nothing to do with thread states. Represents actual, every thread has a life cycle: new, runnable, running, terminated. If we call, then only we will get illegal thread state exception. You cannot restart it. Once a thread starts, you cannot, even after it is terminated. Okay. So yeah, these are the topics we have discussed so far. In the next video, we can see runnable, advanced plus real traps. Thanks for your great time on listening to my lecture. Please subscribe and like for any upcoming videos. Thank you.